Hello, I'm just here to do my presentation. We were working in Jupyter Notebook and we were performing EDA processes to create a predictive model for Lab 5. And this is just an overview of my lab. I had to select the data set, utilize all coding scripts from the lab exercise, perform EDA processes, and create a predictive model. Provide an explanation of your processes, visualize story via Jupyter Notebook. So I need to choose a data set and utilize the coding as in the example. So I once again went to World Data website to get some mock data. I found a car sales mock data that I used. I needed sales data over a time period with multiple categories and models. So, for example, this one, I had a lot of different makes of different cars that I could use, so I could actually select a specific car make from the data set. Um, and again, this for this lab, we're using Jupyter Notebook, and we use this first semester and last lab, so I'm familiar with it. And I'm for this one again, I'm doing two. I'm opening into two labs. So, for example, this is my lab 5. This is my thing with errors, and then this is my actually here's the predictive model that we were following along that was provided to us right here, and then I did the same in lab 5. Okay, so moving on. Again, I did run into errors. I removed the errors from my HTML this time, like I just showed you. I had an errors file, and then I had a clean run through. Um, I found that a lot of the errors had to do with the date formatting, which was in the data set. For this lab, I used the Ford model to get my data, and so this was what was originally in the data set, but this is all we really required was the purchase date and the sales data. So I did, here you'll see we started to create some following along with visualizing the data. This is visualizing the Ford sales time series data, visualizing data using time series, decomposition, trend, seasonality, and noise. This is the chart um, that I came up with, and everything looks pretty good. This is the model to diagnose to investigate unusual behavior. And as I look at my charts, I'm not really seeing a whole lot of unusual behavior right here. You can see that it pretty much kind of flows nicely. This is kind of a perfect curve here for what we were looking for. Um, Moving on. I also did some predicted sales to real-time series data right here in this for Ford sales. And this chart is a visual forecast. Lastly, I completed a comparative chart, so Ford sales versus Buick sales. And you can see here the Ford sales are in blue, the Buick sales are in red. Um, they kind of, there's no real closeness to it. It's just kind of all over the place. I guess it depends who's really buying at the time, either Ford buyers or Buick buyers. Um, or whenever maybe that they had sales, because a lot of people do wait for sales when buying a car, whether it's low interest or um, deals off the price. So when I finished all of my data and went through, one thing I didn't actually show in the um, the PowerPoints was kind of finding the means, which is in here, finding the mean square in the forecast, so the mean squared error for our forecast and the root mean squared error of our forecasts was also added in. And Just go back to my PowerPoint. So I did save the HTML file, and it is right here, just pulling it up, the HTML file with all of my predictions and my models. I found the errors so my conclusion is I worked through it, but I did find that the errors in this lab were a little bit more difficult to troubleshoot. And that is about it for my lab number 5. Thanks.